All right, today we're going to be focusing on predicting products. Before we get going there, what we're going to be focusing on with predicting products is specifically double replacement reactions. A double replacement reaction is when you have two compounds, so here we have sodium chloride and silver nitrate, excuse me, and the ions are going to replace each other. So every ion is going to be paired up with something else. So the silver leaves the NO3 and pairs up with the Cl, and the Na replaces that silver and pairs up with the NO3. That is what is happening during a double replacement reaction. This is our general format of a double replacement reaction. You want to write this down in your notes. This is a test question. This is how double replacement reactions work. So you'll notice A was with X. Well, now A is with Z. B was with Z, and now B is with X. And notice that the positive ion, whatever went first, stays first. So A is first in the formula, and B, which is first, stays first in the product formula. Now, a neutralization reaction is the exact same thing as a double replacement reaction, but it is specific to a reaction between an acid and a base. So a neutralization reaction is a double replacement reaction, but it's between an acid and a base. You're going to want to write that down to know that for the test. And if we look at our format, you'll notice that it's very similar. It was AX. Well, if it's an acid, our A is H. It was BZ. Well, our Z is the OH. So our A pairs up with the OH. This becomes our water. And the B and the X pair up. So it's the same type of process, but it's just specific to an acid and a base. Now, what's important here is these are the products. Every neutralization reaction always makes the same thing, which is water and a salt, just a generic ionic compound. So the actual process of predicting products, again, we're focusing on double replacement reactions. So you'll be given this first half of the reaction, so it's just a matter of knowing that everyone switches places. So the Ca is going to bond with the NO3. And so the important thing here is I'm looking for their oxidation numbers because I'm going to have to write the formula of what happens when these two ions come together. Second, I know that the Ag, my B, is going to bond with the Cl. So I look at my pink sheet and I look up their oxidation numbers because, again, I need to know oxidation numbers in order to write formulas. Once I know what is being paired up with what, then it's just a matter of writing the formulas. Important note here is that sometimes we carry over subscripts and sometimes we don't. For example, the 3 we carry over because that's a part of the polyatomic ion nitrate. But the 2 on the Cl doesn't get carried over because the 2 is only there to balance out the charges. And so again, once we know what the charges are, we can crisscross. The Ca was +2, the nitrate was -1. That's how I get the 2 outside parentheses, and the silver and the chlorine were each 1 apiece, so my formula is just AgCl. We can look at this exact same thing, but with a neutralization reaction. So it's the same kind of rules. So my H is going to bond with my OH, and my Na is going to bond with my SO4. And so I look up the charges of each, and so I know SO4 is -2, which is why I get a 2 right here in front of the Na, and H and OH, there's my water. Because the products of a neutralization reaction are always a salt, so a generic ionic compound, and water. Now, you can write your water, oh, you can't see that, as H2O, or you can write it as HOH. I will take either one on the test. Okay, so let's look at an example here. So here we have A double replacement reaction, but specifically this is a neutralization reaction because I have an acid, because it starts with H, and I have a base, because it starts with OH. So my SR is going to bond with my BR, so we want to look up the oxidation numbers, and my H is going to bond with my OH. So I know that water is already going to be a product, H2O or HOH, so really it comes down to the SR and the BR. And if you look up the oxidation numbers, SR is +2, BR is -1. So when I crisscross, this is what I end up with as a formula. And this would be my answer on the test. Go ahead and pause the video and try to do this example. Okay, so we're looking again at a neutralization reaction. We have an acid because it starts with H, and we have a base because it ends in OH. So I know that one of my products is going to be water. The other one is going to be the combination of Ca and Cl. Remember, Ca comes first in the formula, and so it needs to stay first in the formula on the product side.